Howdy folks, this is Mr. Ryan. We're continuing with our understanding of vectors, and in this video what we're going to do is I'm going to show you how to identify the components of a vector if you're just given a couple pieces of information about that vector. So let's look at this question right here. It says, what are the components of vector B if the magnitude of vector B is 3 and vector B starts at the origin at a 60-degree angle from the positive side of the x-axis? So let's draw a picture of what we're looking at here. Okay, the positive side of the x-axis is right here. It's a 60-degree angle from the positive side, so that means we're talking about a 60-degree angle, maybe right about there. That looks about right. And it says it has a magnitude of 3. So the vector, let's see, here we go, 60-degree angle. It has a magnitude. The magnitude of the vector is 3. Remember that the magnitude of a vector is the length of the arrow, And what I had said in the last video is that the length of the arrow basically creates a right triangle with the x-axis. Now it could create a right angle with the y-axis as well. That's fine. We just typically do it, at the beginning level we usually do it with the x-axis. Okay. So what's happening here is this is a 60-degree angle. We're told that that's a 60-degree angle. That the magnitude, the length of this arrow is 3, and what we want to know is what are the components of vector B. So vector B, we want to know what the xy coordinates are, what the components are. And so here's what I want to show you is that basically what we're dealing with here is a 30, 60, 90 right triangle. So let me go get one of my magnetic 30, 60, 90s here. I'm going to put this maybe right down here and show you an example. Let's create another xy, another origin. There's the x-axis, there's the y-axis, and what's happening here is we have this, because we have this this vector with a 60-degree angle, see that? With a 60-degree angle, that since we're drawing, making it a right triangle here, that means that the angle up here, of course, is 30 degrees. So we're dealing in a 30, 60, 90 right triangle. And so if we're trying to find the components of the vector, what we're basically looking for here is we're looking for the length of this and the length of this. Okay, these are the two legs. We want the lengths of the legs of this right triangle. And if we understand our 30, 60, 90 right triangle, we can remember that the short leg is always half of the hypotenuse. So if the hypotenuse is 3, that means this short leg right here, that's going to be half of 3. That's 3 over 2. And we know that the vertical, the vertical here is the longer leg, and we know that the longer leg of a 30, 60, 90 right triangle is the short leg times the square root of 3. So the short leg is 3 over 2, so this would be 3 square root of 3. It'd be 3 square root of 3 over 2. And therefore, the components of the vector, this coordinate right here is 3 over 2 and 3 square root of 3 over 2. And so those are the components. 3 over 2 and 3 square root of 3 over 2. All we had to use here was our knowledge of the side lengths of a 30, 60, 90 right triangle. Okay, let's do another problem. All right, this one says, what are the components of vector W if the magnitude of vector W is 5 and vector W starts at the origin at a 150-degree angle from the positive side of the x-axis? Okay, well, let's look at this here. Here's the positive side of the x-axis. Vector W starts at the origin here, and from here, from the positive side of the x-axis, we want to go 150 degrees. Well, we know that from here, if we go up to here, that's 90 degrees. And then we have to go a little bit more. Now, if we go all the way over to here, that's 180 degrees. So that's a 180 degree angle over here. So the vector's probably over here somewhere. It's probably doing something like that. That's about 150 degrees. Now, here's what you need to understand. If you want to be able to answer this question, you need to identify. So the first thing you're going to do this, one, is identify the reference angle. Identify the reference angle. Okay, because you don't want to do this with a 150 degree. You can't make a 150 degree right triangle. It's not possible. 150 degrees is more than 90 degrees, and so you can't have a 150 degree right triangle. So what we're going to do here is we're over in quadrant 2, and we know that in quadrant 2, to find the reference angle, we have to do 180 minus the angle measure. So 180 minus theta. And 180 minus 150 is 30. So really, instead of dealing with a 150 degree angle, we're dealing with a 30 degree angle. So we can identify the components of this vector by using a 30 degree angle. And so that's basically going to create a 30, 60, 90 right triangle again. 30, 60, and 90 right triangle. And so it would look something like this. Okay, so let's go ahead and I'm going to redraw this. And I'm going to use this. Okay, I'll put in my 30, 60, 90 right triangle here. And let's say that this is our vector right here. Put an arrowhead at the end. All right, there's our vector. We want to know the components of vector W. This is vector W, and its magnitude is 5. So that means the length from here to here is 5. That's the length of a hypotenuse of a right triangle. Not just any right triangle, a 30, 60, 90 right triangle. How do we know it's a 30, 60, 90 right triangle? Well, because we know that the vector is 150 degrees off of the positive side of the x-axis. And that leaves another 30 degrees right here. The reference angle for 150 degrees is 30 degrees. And so now we have 30, 60, 90 right triangle. And we know that a 30, 60, 90 right triangle, here we go, the height here is the short leg of the 30, 60, 90. And we know that the short leg of a 30, 60, 90 is half of the hypotenuse. So half of 5 is 5 over 2. So the vertical distance is 5 over 2. And the vertical distance is the y coordinate, right? And it's positive because it's going up from the x-axis. So we know that 5 over 2 is the y coordinate of the vector, or the y component. Now we just need the x component. And here we know that the long leg of a 30, 60, 90 right triangle is equal to whatever the short leg is. If the short leg is x, then the long leg is x times the square root of 3. And so all we have to do is multiply the square root of 3 times the short leg, which is 5 over 2. So that's going to be 5 times the square root of 3 over 2. Now, here's the thing. That's the length from here to here, but we're moving to the left. We're in quadrant 2. And in quadrant 2, our x-coordinate is negative while our y-coordinate is positive. So this is actually going to be, the component is going to be negative 5 square root of 3 over 2. So negative 5 square root of 3 over 2. That's the components of vector W. Okay? I think we should do a few more examples. All right, let's look at this one. We've got what are the components of vector t if the magnitude of vector t is 12 and vector t starts at the origin at a 315 degree angle from the positive side of the x-axis. So 315 degree angle, you know, if we're starting here, it's going up to 90, then it's coming down, right? That's 180, then it goes to 270, it's somewhere way over here. Okay, so it's kind of pointing down at that angle, right? The first thing we need to do is identify the reference angle. So we've got to figure out which quadrant that this 315 degree is in. Well, it's between 270 and 360. That puts it in the fourth quadrant. And if it's in the fourth quadrant, then to find the reference angle, we're going to do 360 degrees minus 315 degrees, which is 45 degrees. So our reference angle in this particular case is 45 degrees. It's actually at a 45 degree angle below the x-axis on the positive side. So here's probably what we have. We've got a vector, we've got an arrow that's just pointing straight down right there. And I'm going to use my 45, 45, 90 right triangle to help me draw this vector. There we go. So it probably looks like this, right? That's our vector at a 315 degree angle. That's 315 degrees, but it's at a 45 degree reference angle. And so now if we were to create a 45, 45, 90 right triangle, this is also a 45 degree angle down here. And now we can use a 45, 45, 90, what we know, the proportions of a 45, 45, 90 special right triangle to identify the components of this. I didn't really draw this quite right. It should have gone out to here. Hang on. Let me fix this. Let's see here. That's still terrible. It's not quite straight, but it's better than what we had before. Now we know that the magnitude of this vector is 12. So t, the magnitude of the vector is 12. And so the distance from here to the end of the arrow is 12. Well, what we know about a 45, 45, 90 right triangle is that the legs, let's say that the legs have a length of x. Remember, the two legs are equal, so they're the same measure. That means that the components of this vector are going to be the same values, except one's going to be negative and one of them is going to be positive. And we know that the relationship between the leg of a 45, 45, 90 and the hypotenuse is x times the square root of 2. So we know that this is x squared root of 2. So if 12 is x square root of 2, 12 equals x square root of 2. All we have to do is divide by the square root of 2 on both sides, and we have the length of one of the legs. So the leg is 12 over the square root of 2. But we don't want to leave a square root of 2 in the denominator. We want to rationalize the denominator. And the way we're going to do that is we're going to multiply by the square root of 2 over the square root of 2. That's going to give us 12 times the square root of 2 over square root of 2 times the square root of 2 is 2. And now we can reduce this. 12 divided by 2 is 6. And so now our leg length is 6 times the square root of 2. And so this distance from here to here is 6 square root of 2. And the distance from here to here is also 6 square root of 2. And now the components of our vector, our x-coordinate is going to be positive. So vector t is going to be, the x-coordinate is a positive 6 square root of 2. The y-coordinate is going to be negative because we're going down from the x-axis. So negative 6 square root of 2. And these are the components of vector t. Okay? I think we should do probably a couple more examples. All right, here's our next one. If you want to, why don't you pause and try this? It says, what are the components of vector d if the magnitude of vector d is 1 and vector d starts at the origin at a 240 degree angle from the positive side of the x-axis? Remember to identify the reference angle, and then you're probably going to use a special right triangle to identify the components. All right, if you weren't sure how to start this, hopefully you did. Hopefully you were successful and you got the components, and we're just going to check. But if you weren't sure how to start, follow along with me. I want to know the reference angle. So first I need to figure out which quadrant a 240 degree angle is in. So the first quadrant is 0 to 90. Second quadrant is 90 to 180. And then the third quadrant is 180 to 270. Okay, well 240 is between 180 and 270. So this must be in quadrant 3. If it's in quadrant 3, we know we can find the reference angle by subtracting 180 from that angle. So if we do 240 minus 180, we get 60 degrees. So it's a 60-degree reference angle. From here, from the x-axis, we have a 60-degree angle, and that means I'm going to use a 30, 60, 90 right triangle. And it's going to look like this right here. So I've got a 60-degree angle here, so my vector is going to look something like that. Let me go ahead and put my dashed line in here to make my right triangle. There we go. Okay, so this is my vector, and it has a magnitude of 1. So the magnitude of vector D is 1. The distance from here to here is 1, a hypotenuse of 1. And it's a 30, 60, 90 right triangle, right? Because this is a 60-degree angle and this is a 30-degree angle. Okay? Now, in a 30, 60, 90 right triangle, we know that the short leg is half of the hypotenuse. Well, if the hypotenuse is 1, half of 1 is 1/2. And so the distance from here to here must be 1/2. Now we need the distance from here down to here, and we know that in a 30, 60, 90 right triangle, that the length of the long leg is square root of 3 times the length of the short leg. So we got to do square root of 3 times 1/2. So square root of 3 times 1/2. We're going to multiply the square root of 3 times the numerator, and it's going to become the square root of 3 over 2. And so the distance from here to here is going to be the square root of 3 over 2, right? And so now the coordinates of this point, the components of this vector, this is vector D, is going to have the coordinates, or the components, x first. Well, we're going backwards along the x-axis by 1/2, so that's going to be negative 1/2. So negative 1/2, comma. Now we're going down from the x-axis by square root of 3 over 2, so that's going to be negative square root of 3 over 2, and there's the components of vector D. I think we should probably do one more example. All right, this will be our last example, but you'll have plenty of work in the set of problems that I give you. It says, what are the components of vector A if the magnitude of vector A is 1 and vector A starts at the origin at a 135-degree angle from the positive side of the x-axis? Well, we'd like to know what quadrant a 135-degree angle is in. We know that quadrant 1 goes from 0 up to 90, so it's not in the first quadrant. Quadrant 2 goes from 90 up to 180. Well, this is 135. That's between 90 and 180. And the way that we find the reference angle is we subtract our angle from 180. So 180 degrees minus 135 degrees is 45 degrees. So this vector has a 45-degree angle from the negative side of the x-axis and going up. So let's draw that. And it's a 45-degree angle, so I'm going to use my 45, 45, 90 right triangle. I'm going to put it right here. And then I'm going to draw a vector here. All right, we got that. And then I'm going to kind of draw the dashed line here. There we go, to make the right triangle. Here's my vector, right? And we want to know the components of vector A. Well, the magnitude of vector A is 1. So the distance from here to here is 1. And so now we want to know, and this is a right triangle, since this is a 45-degree angle, that makes this a 45-degree angle also. And so we can use a 45, 45, 90 right triangle. Well, remember that the relationship in a 45, 45, 90 right triangle is that the two legs are equal and that the hypotenuse is square root of 2 times the length of the leg. So if the length of the leg is x, then the length of the hypotenuse is square root of 2 times x. So we're going to do square root of 2 times x is equal to, in this case, 1. Then we're going to divide by the square root of 2 on both sides. And we're going to get x is equal to 1 over the square root of 2. But we can't leave it like this because we want to rationalize the denominator. So we're going to multiply by the square root of 2 over the square root of 2, 1 times the square root of 2 is the square root of 2, and the square root of 2 times the square root of 2 is 2. And so the distance, the length of the leg, is square root of 2 over 2. So from here to here, we've got the square root of 2 over 2, and the height, the length of this leg, is also square root of 2 over 2. And so now to identify the components of this vector right here, at this point, vector A has the components, okay? The x-coordinate is going to be negative because we're going backwards along the x-axis. So that's going to be negative square root of 2 over 2. And then the height, the y-coordinate, we're going up from the x-axis, so that's going to stay positive. It's going to be the square root of 2 over 2. And there are the components of vector A. So here's what you need to do with all these problems. You got to do a lot of these. You got to get really good at these. And what you're going to do is you're going to start seeing some of the same numbers over and over and over again. And there's a good reason that you're seeing the same numbers over and over and over again, because you're mainly using you're only using the 30, 60, 90 triangle and the 45, 45, 90 right triangle, okay? And I'm doing this on purpose. I'm leading you to an understanding. You're understanding vectors, and we're going to take this knowledge of vectors, and we're going to learn even more stuff with it. But that's all I have for you in this video, and I hope you have a great time learning awesome math stuff.